I hope everyone's having a great evening. I am Mr. Ish. Thank you for joining me. We mark this evening here with an interesting video, a relevant video, electron configurations of ions. We're looking here at only 4 examples, and remember, for these elements we're looking at, everything is dictated by the octet rule, the desire of an element in terms of its ionic form to approach that configuration of a noble gas. You remember all of that, and you will see all of that. Lithium has an atomic number 3. When you look at it in terms of its electron configuration, you're looking at 1s2, 2s1. But you know, lithium is an alkali metal. When it will become an ion, it will become a cation. What does this lithium positive mean? It means it's lost an electron. If you have something like lithium chloride, chlorine has pulled an electron away to fill its own outer shell, and it has pulled that, and lithium has lost one. This means you have now 2 electrons only, and it'll be 1s2. What does 1s2 indicate? It indicates the electron configuration of helium. When you have a basic element in terms of an ionic form, the ionic forms will mimic an electron configuration of a noble gas. Keep that in mind. In the 4 examples, this is example 1, everything you will see will be related to that central theme. Our next example is magnesium. Magnesium has an atomic number of 12. It has 12 electrons. You will look at it. This right here is neutral magnesium. 1s2, 2s2, 2p6. That gives you 10 electrons, and you do 3s2. Now you know you have 12 electrons. When magnesium undergoes a reaction, it's an alkaline earth metal, like something you can say magnesium oxide. It will lose 2 of its electrons in terms of an ionic bond to oxygen, which is more electronegative. It will become Mg2+. What does that indicate? It means it's got 10 electrons. When you do the electron configuration of a cation, such as this, it should mimic an electron configuration of a noble gas, and it will 1s2, 2s2, 2p6. These are 10 electrons, but these right here represent the electron configuration of neon, so you know you're good. Remember, the electron configuration of ions for these non-transition metal elements should match an electron configuration of a noble gas. Nitrogen is not a hard one. It has an atomic number of 7, which means it has 7 electrons. Its electron configuration is 1s2, 2s2, 2p, 2p3. 4 plus 3 gives you 7 electrons. When it will form an ion, it will be an anion because it will want to absorb 3 electrons so it can become a noble gas configuration. And you know that's going to be this, nitrogen with the 3 minus, meaning an ion with a charge of 3. It has received 3 electrons. And this now will represent 10 electrons. It will be 1s2, 2s2, 2p6, and this right here will represent the noble gas configuration of neon. So you can see very much here the ions have electron configurations equal to those of noble gases. We'll end over here now with this last one, which will be chlorine. You know chlorine is a halogen. It has an atomic number of 17, so therefore it has 17 electrons. What will it be? It will be 1s2, 2s2, 2p6. Then you'll come to 3s2. And then let's see what we have. We have 10, 11, 12, and then we'll have 3p5. That's your 17 electrons. When it will become a ion, it will want to absorb 1 more electron, so it can have full 6 electrons here in the p orbital and complete its octet, because this 2 plus 5 plus that 1 will give you your 8 electrons you need in that outer shell. It will be chloride with a negative 1. It will have 18 electrons. 1s2, 2s2, 2p6, 3s2, 3p6. What does this equal to? 18 electrons, but it equals to the electron configuration of the noble gas argon, and there it is. Every single element which you will study other than transition metals will generally follow the rule such that its ions, whether it's a cation or anion, will want to mimic the noble gas configuration when it has become an ion from a neutral element. That is perhaps the most important lesson of this video, and you've seen how everything has come about with the 4 examples I provided. Thank you for watching.